Hola a todos, bienvenidos nuevamente, soy Cecilia Chávez y el día de hoy daremos paso a la lección 6 de nuestro módulo 2 y en el cual haremos un estudio sobre los fluidos mecánicos y en la gramática estudiaremos el primer condicional en inglés. So everybody, welcome back again. Lesson 6. Fluid Mechanics. An object is buoyed up by a force equal to the weight of the fluid displaced. Archimedes' principle. Objective: to understand the basic concepts of fluid mechanics. Why study fluid mechanics? The primary reason is not even technical, it is cultural. A physicist is defined as one who looks around and understands at least part of the material world. Fluid mechanics is encountered in almost every area of our physical lives. Blood flows through our veins and arteries. A ship moves through water and water flows through rivers. Airplanes fly in the air and air flows around wind machines. Air is heated and cooled in our homes, and computers require air to cool components. All engineering disciplines require some expertise in the area of fluid mechanics. Fluid mechanics. Fluid mechanics is a branch of physics concerned with the study of liquid, gases, plasmas, and the forces on them. Fluid mechanics has a wide range of applications, including mechanical engineering, civil engineering, chemical engineering, biomedical engineering, geophysics, astrophysics, and biology. Fluid mechanics can be divided into three divisions. Hydrostatics, that studies the mechanics of the fluids at absolute and relative rest. Kinematics deals with the translation, rotation, and deformation of fluid without considering the force and energy causing such a motion. Dynamics that prescribes the relation between velocities and acceleration and the forces which are exerted by or upon the moving fluids. The history of fluid mechanics. The science of flow has been classified into hydraulics, which developed from experimental studies, and hydrodynamics, which developed through theoretical studies. In recent years, however, both have emerged into the single discipline called fluid mechanics. Hydraulics developed as a purely empirical science with practical techniques beginning in prehistoric times. As our ancestors set out to engage in farming and their hamlets developed into villages, the continuous supply of a proper quantity of water and the transport of essential food and materials posed the most important problems. In this sense, it is believed that hydraulics was born in the utilization of water channels and ships. Characteristics of a fluid. Matter exists in two states: the solid state and the fluid state. This classification of matter is based on the spacing between different molecules of matter as well as on the behavior of matter when subjected to stresses. Because molecules in solid states are spaced very closely, solids possess compactness and rigidity of form. The molecules in fluid can move more freely without the fluid mass, and therefore the fluids do not possess any rigidity of form. The properties of fluids are viscosity, surface tension, compressibility. Viscosity. It describes the internal friction of a moving fluid. A fluid with large viscosity resists motion because its molecular makeup gives it a lot of internal friction. A fluid with low viscosity flows easily because its molecular makeup results in very little friction when it is in motion. Gases also have viscosity, although it is a little harder to notice it in ordinary circumstances. Surface tension. Surface tension is a contractive tendency of the surface of a fluid that allows it to resist an external force. Surface tension is an important property that markedly influences the ecosystems. Whenever a fluid is left to itself, the fluid tends to attain the minimum surface area possible. Compressibility. In thermodynamics and fluid mechanics, compression, also known as the coefficient of compression or isothermal compression, is a measure of the relative volume change of a fluid or solid as a response to a pressure change. There are two branches of fluid mechanics. Fluid statics or hydrostatics is the branch of fluid mechanics that studies fluids at rest. It encompasses the study of the conditions under which fluids are at rest in a stable equilibrium. Hydrostatics are categorized as a part of the fluid statics, which is the study of all fluids, incompressible or not, at rest. Fluids dynamics is the study of fluids in motion. The main equation required for this is Newton's second law for accelerating bodies. Expressing fluid pressure in terms of a vertical liquid column makes perfect sense when we use a very simple kind of motion balance pressure instrument called a manometer. A manometer is nothing more than a piece of clear tubing filled with a liquid of known density situated next to a scale for measuring distance. The most basic form of a manometer is the U-tube manometer. Types of manometer. Piezometer. Piezometer is the simplest form of manometer which is taped into the wall of pressure conduit for the purpose of measuring pressure. Open manometer. Open manometer is a tube bent into a U shape to contain one or more fluids of different specific gravities. It is used to measure pressure. Differential manometer. Differential manometer cannot measure pressure but can measure pressure difference. Frequently in hydraulic problems, difference in pressure is more useful information than the pressure itself. Units and dimensions. Physical quantities are given by a few fundamental quantities or their combinations. The units of such fundamental quantities are called base units and they have 7-dimension units. The combinations of them are known as derived units. The system in which length, mass, and time are adopted as the basic quantities and from which the units of other quantities are derived. It is called the absolute system of units. Pressure and temperature. In our study of fluid mechanics, we often encounter pressure. It results from compressive forces acting on an area. Pressure measured relative to atmospheric pressure is called gauge pressure. It is what a gauge measures if the gauge reads zero before being used to measure the pressure. Absolute pressure is zero in a volume that is void of molecules, an ideal vacuum. Volume and surface forces. Generally speaking, fluids are acted upon by two distinct types of force. The first type is long-range in nature, that is, such that it decreases relatively slowly with increasing distance between interacting elements, and it's capable of completely penetrating into the interior of a fluid. Gravity is an obvious example of a long-range force. The second type of force is short-range in nature. It is most conveniently modeled as momentum transport within the fluid. Such transport is generally due to a combination of the mutual forces exerted by contagious molecules and momentum fluxes caused by relative molecular motion. Continuum mechanics. It is a branch of mechanics that deals with the analysis of kinematics and the mechanical behavior of materials modeled as a continuous mass rather than as discrete particles. The French mathematician Austin-Louis Cauchy was the first to formulate such models in the 19th century. Continuum mechanics deals with the physical properties of solids and fluids which are independent of any particular coordinate system in which they are observed. These physical properties are then represented by tensors, which are mathematical objects that have the required property of being independent of coordinate system. Bernoulli's principle. In fluid dynamics, Bernoulli's principle states that an increase in the speed of a fluid occurs simultaneously with a decrease in pressure or a decrease in the fluid's potential energy. The principle is named after Daniel Bernoulli, who published it in his book Hydrodynamica in 1738. Bernoulli's principle can be applied to various types of fluid flow, resulting in various forms of Bernoulli's equation. There are different forms of Bernoulli's equation for different types of flow. The simple form of Bernoulli's equation is valid for incompressible flows. Knowing about fluid mechanics is relevant to a variety of engineering disciplines ranging from the design of airplanes and automobiles to airspace guidance and control, to the prediction of the global climate, to biofluid dynamics, to flow over magnetic tapes and disks, to industrial fluid mechanics. Fluid mechanics can be mathematically complex and can best be solved by numerical methods, typically using computers. A modern discipline called computational fluid dynamics, CFD, is devoted to this approach to solving fluid mechanics problems. Now it's time to do the activities.